Oh, well, hello. You're just gonna see a video, I guess, of me. Hi, everybody. So this question was asked. So this is from chapter 22, problem 31. And yeah, so here we go. So basically, it says in this example, in example 22.6, so you can go back and look at the example if you want to. The length of a 60-watt, 240 ohm light bulb filament was calculated to be 60 centimeters. And so, if the potential difference across the filament is 120 volts, what is the strength of the electric field inside the filament? So, um, yeah. So basically, what I've done here. So here's like a light bulb, and then here's the light bulb filament right here. Is the squiggly stuff right there, and then basically I have it connected to a 120 volt light bulb. So we know the potential difference. Like you could say here is 120, and then down here is 0. So that's the potential difference is 120 volts. And if I so and then again they want us to find the electric field. So the electric field, if we recall from the previous chapter, is the change in potential difference divided by the change in position, the path length. So basically, the length in that case is going to be this. So this is me. So basically, I took this and I'm stretching it all out. So if I took each end of this filament and stretched it all out, it would maybe look like this. And then what I'm going to do is I'm going to say, well, this is the length, the original length L, right? And I know the difference, the potential difference across here is 120 volts. And so then using this equation that I can calculate the electric field, it's just going to be the potential difference, which is 120 volts, divided by the path, which is the length L, but in this case, it's 60 centimeters. So that's going to be 0.6 meters. And so I can calculate that 120 divided by 0.6, and I get 200 volts per meter. So there you go. There's the electric field. Then it says, suppose the length of the light bulb's filament were doubled. So now this becomes twice as big. Right? You can imagine I can make a, right, becomes twice as big. Something like that. Kind of silly, but yeah. So it were doubled without changing its diameter. So diameter doesn't change, or the potential difference across it. So it's still 120 volt potential difference across it. Would the electric field, what would the electric field in this case be? Well, it's still 120 volts, but now this becomes double. Basically, it's going to reduce this by 2. It's going to have that because this is going to be 1.2 now instead of that. So the electric field then becomes 100 volts per meter. So that's part B. This is part A. All right. And then remembering that the current in the filament is proportional to the electric field. So that the current in the filament is proportional to the electric field. So easier way to write that out is for me to go, well, the current I is proportional to the electric field. So what is the current in the filament following doubling its length? Um, so we doubled the length. So now we doubled the length. So by doubling the length, this gets reduced by 2. So if this gets reduced by 2, so if the electric field is halved, that must mean then the current is also halved. So the current will also be reduced by 2. All right. And then lastly, it says so that's part C. The current would be half of what the original current was. And then for part C, what is the resistance of the filament following the doubling of its length? So what's the resistance following doubling its length? I can use that equation that the resistance is the resistivity. times the length divided by A. That's the cross-sectional area. So, and basically, so following the doubling of its length. So the length is doubled. So this has become, again, the material didn't change, and they told us the cross-sectional area didn't change. So if the length is doubled, if this increases by a factor of 2, then that means the resistance must increase by a factor of 2. So if the resistance was originally 240 ohms, then it's the new resistance is going to be double 240. So I think that's 480 ohms. And there you go. All right. Thanks. Bye.